So let me talk to you about two of my favourite days at Plymouth. One is graduation. We are in a fantastic situation, and we typically have our graduation up on the Hoe, which has the most amazing backdrop, and is the best graduation I've been to. And I've been to quite a few, especially for our undergraduates, I think. But as a staff member, it's wonderful to see everyone graduate. So that's one of my favourite days. The other is our project showcase, which I mentioned in my introductory video, and I wanted to talk about projects a little bit. It's my favourite day because I get to see these amazing projects that our students have created. I was just going to whiz through some of my favourite ones. Hopefully you've seen a link to the Mars rover that one of our students built a few years ago. He built it from the ground up, everything: power systems, communication systems, the solar panels, the microprocessor. It had 3 different microprocessors inside, 2 different communications frequencies. He designed the antennas. Every single part of that he built, and it was quite fabulous. So that was really a showpiece of his skill. Other projects that I've really liked, my favourite from a couple of years ago was a student. His father had developed Parkinson's, so his hands had started to shake, and this had a huge impact on his quality of life. He found that simple things like eating cereals or eating were becoming difficult, and that has it's a compound effect on mental health and all sorts of things. These things are difficult to bear. So he'd come up with a project where he developed a little barrel-shaped device that you could plug in a fork or a spoon, and while your hand shook, the spoon would remain completely still. What a fantastic piece of engineering! What a fantastic idea! And we've had students develop, on the master's course, tool holders that, while you wobble them around, they'll hold the bit still. And it's the same principle. Wonderful control engineering. So I was particularly impressed with that. We had a student a few years ago, near when I first started in Plymouth. He was with the R&I, so he was, an industrial guy finishing his degree with us. And his project was, he said himself, the R&I spend 900 man hours, or he said waste 900 man hours a year looking for lost children. He said, actually, no, waste is the wrong word. We spend 900 man hours a year looking for lost children on beaches, and this is not really our job. So he came up with the idea for a badge or tag or a wrist strap, and the idea was it worked with low power Bluetooth and paired with your phone, and you could set the distance. So you could say, right, young Johnny, I would like you to stay within these rocks. Don't go past the rocks. And if a young Johnny or Jasmine, wandered past this, it would immediately start alarming your phone. You go, I told you not to wander off. Come back here. And so he developed and designed that. And I think they're hoping to actually roll it out, after he's graduated a few years back now. But they were looking at actually rolling it out on the beaches and adding a sun sensor. So not only would it, and these things would come in at less than sort of £5, £10, and pair with your phone, and it would also have a sun sensor. So based on either UV or little UV detector, and on the app you'd tell it what factor was on, and it would remind you, slip slap slop, it's been 20 minutes with a factor 50, you need to reapply. So that was quite a clever idea. We've seen some good ones, some underwater vehicles. A student from Babcock. Obviously, you can't put divers in the water when ships are pinging their sonars and other things like that. It's not safe. So he developed a little tethered UAV, underwater vehicle. Yeah, that works, doesn't it? It's a submarine, and that could go down and inspect the underneath of ships and submarines when divers couldn't go in the water. And we've had a few students build electric bikes from scratch. That's quite an impressive bit of work. Often lots of explosions when students are working with power, because in theory it seems simple, but when you apply it practically, you get voltage spikes and transients, and these things tend to explode MOSFETs. So you can always tell when a student's doing a project involving power because of the popping, banging, and the smell of smoke in the lab. So those are quite impressive. One of our students, Max Simmons, who hopefully you saw the video of his placement project he built, he did for his third-year project, he built a self-balancing unicycle. So again, a little bit of control engineering, motors, and just rather impressive. So what else? What are my other favourite projects? We've had some ultrasonic levitation, where you use ultrasound and sound to pick up and move small objects. The benefit of that is they don't have to be magnetic. You can pick up anything and move it. And one application I saw for that is actually tactile feedback. So you'd have a little ultrasonic array, and if you're in VR, when you reach out to push switches, the ultrasonic, sort of tractor beam can provide some sort of tactile feedback, so you feel like you're actually pressing buttons. Have I missed him out? What else have I seen that's been particularly good? On the robotics side, I saw a fantastic one. The student was doing a much more of a research project, and it was looking at tendons. So these were like, I can only describe it as like, well, this slightly grim, looks like strips of tendon, but they are electrically controlled. So you put a current through them and they contract and expand. And I'm sure you can see the potential for that for sort of lifelike robots, which is, but it was amazing to look. And this is why the project showcase is one of my favorite days. So I get to walk around, and it's like, for me, being a child again, none of you will remember Tomorrow's World, I expect, but I get to see these amazing pieces of work. Some of them are outside of my subject. And a little brag about one of my own students. Last two, we've had lots of audio projects. I mentioned we had lots of our graduates who've gone to Allen and Heath and into the sort of music industry. He developed, it was a hybrid MOSFET, which is a classic amplifier that you normally buy with a valve as well, preamp for his guitar. And if you're into audio, and you've got deep pockets, you can buy these amplifiers, and they use valves because they think it gives a clearer, cleaner sound. So that was quite impressive. And then one of my own students, I'm a communications engineer, so I do telecoms, radio, and this student did he did his placement at DSTL, and so they're interested in obviously the radio side of detection, and drones were a big thing at the time. So he did a drone detection system. So it would simply detect and identify the direction of drones in it. So he designed the antenna that would sweep, and it would pick up both 5 gigahertz, 2.4, and sort of 8 and 433 megahertz frequencies, and it would identify range and distance and pick up the drone so it could detect them. Amazing piece of design work. I mean, I would expect that sort of thing from someone who'd been working in the field, in the industry for several years. The work he did was exceptional. So that's my interesting projects that I've seen, and I'll leave it there. Good to talk to you.